All right. Okay, thanks very much. My project is basically, it's a PhD project, and like Jennifer, I always end up doing things at midnight. It's kind of a part-time project, and other times I'm an environmental consultant, so here's my research hat. Falls under UCT Oceanography Department, whereas the only supervision can come from UCT, and then Baywell Center for Research and Education. And Mike Roberts is my project supervisor. Okay, just to put something into context, and I hope which is the pointer? Ah, there we go. Okay, got it. Thanks. All right. Basically, we've got the Agulhas current coming down here, and if I've got enough time after the presentation, I'll just show a little animation. But basically, you've got the current coming past, and you've got this area here, which is called the KZN Bight. So after sort of Richards Bay area, there's an indentation in the coastline, and you can see there's a shelf area. I don't know if you'll be able to pick up the bathymetry, but there's quite a drop-off over here. And then you've got a shallow shelf in this area. Then you've got Durban. And then south of Durban, the contours basically go in again. So you get a very narrow shelf all the way down the Transkei until you get to the Agulhas Bank and then your Agulhas retroflexion at the bottom here. And then that's going back into the rest of your gyre. In terms of the Durban Eddy, it's a little offshoot. So the Agulhas current is coming past over here. There's your bathymetry again. So you can see how it shallows in this area, south of Cape St. Lucia. And then it steepens again just south of Durban. So the Durban Eddy, it's a semi-permanent, relatively closed cell cyclonic circulation that exists south of Durban. There's a strong Agulhas current, as I say, coming past. And you get this lead-trapped feature. So as the current leaves this area, it's like an offshoot and results in a cyclonic circulation. It's almost like if you're coming down a river and you see as you're shooting past, then sometimes the river widens and you'll get a slackness of currents by the river bank, and then so often you'll get a whirlpool on the other side. And that's almost the same sort of physical forcing mechanism. So in our case, we've got a strong current offshore. We've got a couple of current meters that were installed as part of the program, which I'll take you through in the next slide. But basically, you can see the one that's offshore, which is in about 500 meters, shows a strong Agulhas current. These are stick vectors. They go in the direction of the current and showing the current speed. So you can see that the current is going in a southwestward direction. So that's offshore, southwestward with the Agulhas current. And then on the inshore, this is this little one at the bottom. That mooring is just off Durban, about 2-3 k's off the whaling station, and you can see the currents are counter to that, so that's going northeastward. Okay. Right, in terms of eddy characteristics, just to take you through, an eddy is a small rotating current. It's cut off from the main current, so it's almost like a cut-off lobe or a meander. When you look at oxbow lakes, it's almost the same sort of physical phenomenon. Cyclonic eddies have cool core temperatures, whereas an anticyclonic eddy, which is going the other way, anti-clockwise, have warm cores. The importance for the cyclonic eddy is you get this doming of in the center, and that results in upwelling. So that's the important part for the ecology. The nutrients are brought up with that doming, and that is important for downstream effects, which I'll go through just now. In contrast, an anticyclonic eddy, which would be like a warm Agulhas current ring, has downwelling, and you don't get as much productivity. Also, in terms of the sea level, you have something called the sea surface height or sea level anomaly. In terms of a cyclonic eddy, there's a depression of that, whereas you get doming where you've got an anticyclonic eddy. So you can actually look at satellite altimetry to determine where your eddies are as well. Okay, just to take you briefly through the ASEP, that's African Coelacanth Ecology Program, KZN Bight Research Program. We had a line of ADCPs, which is an ADCP is an acoustic Doppler current profiler, so it's measuring your currents from the bottom all the way to the surface. These are moorings that are put at the bottom, looking up. So we had a mooring off Durban and an offshore mooring, which I spoke about just now, in 500 meters of water. Then we had a temperature array, thermistor array in the middle. So that's just measuring temperature at different levels in the water column. There were other moorings as part of the program. I'm not going to go into that, off Richards Bay. Then I had another mooring, which is part of Saki Saikor at Umkomaas. And then Sizela, we had a mooring that was put in for part of the program. In addition to that, we had 2 research cruises, and this graphic basically shows the grid that was used for the research cruises. I've also deployed satellite track drifters to study the Eddy, and using satellite imagery, MODIS and MERIS. Okay, the Durban Eddy, in terms of the first mooring cruise we did, you can see here's a graphic of chlorophyll A, and you can see the higher concentrations further north with shelf edge upwelling. But one of the hypotheses for this project was to say, is the nutrients that have been brought up by this Durban Eddy, is that supplying one of the suppliers to this shelf area in the KZN Bight? So you can look at our first little cruise. We got this beautiful eddy that's at the surface. You can see the Gullis current coming past, and then that counter current flow. Just an example of an eddy cycle. The eddies are semi-permanent. They spin up, and then they'll migrate down the coast. So basically, you can see here, this is during February 2009. The eddy starts spinning up over here. And there's another little eddy at the bottom here, which is starting to break away, and it's moving down the coast. So the eddy will spin up. It'll reside in the area for a while. Okay, this is over a few days. This is the 11th of February. It's still spinning up here. It's starting to leave the coast here. There's a little bit of filament of cold water and higher productivity as it starts to leave the area, and then it starts to migrate down the coast. So you can see by the 22nd of February, it's starting to migrate, and it flattens out on the inshore region of the Gullis current as it moves southwards, in contrast to an Gullis meander or an Natal pulse, which people might have heard about, which is it's actually a sort of meander in the actual Gullis current itself, and that actually gets larger as it moves down the coast. Okay, one of the characteristics of the eddy is that there's a lot of current reversals. So this is at the top, that's those stick vectors again, that's showing the stronger Gullis current offshore. This graph here is the same period that I showed for the previous slide where I had all those that satellite imagery. So you can see on the Durban inshore area, at the start of when that eddy occurred in the beginning of February, you get that northeastward flow. It pulsates a little bit while it's sitting there. It just pulsates, and eventually it breaks away, and then you can see there's a slight reversal to southwestward flow. At the other mooring, I've got the temperatures at the bottom. There is a little bit of a drop of temperature when the eddy comes through, but you can see the drop when I spoke about that filament of water as it started to break away. That was the period there where it went down to as low as 16 degrees at Taoxide mooring and Sizela. So that's quite a drop in terms of temperature for inshore regions of Durban anyway. And you can see in Sizela mooring, which is further to the south, about 90 km to the south of Durban, that first little eddy I showed that was breaking away, there you can see that northward, that shift to northeastward flow, then a resumption to southwest with the Gullis current, and then as the eddy moved through, going back, reversal back to northeast. Okay, what I've done is I've looked at the currents in quite a lot of detail, together with the satellite imagery, using the currents as a proxy for when the eddy is present and when it's not. What this shows is it's 6 months of data. Okay, so we had 18 months of data. So this is the first 6 months, the second 6 months, and the third 6 months, going from March 2009 to September 2010 at the bottom. The areas in black are where the eddy has occurred. So when I've looked at the currents and the satellite imagery together and said, okay, the eddy is happening. So you can see there's periods where and it's quite inconsistent. So some periods are quite long, the eddy's around, it breaks away. And this is when the eddy is present between the area of Durban and Sizela. So then you can have these inter-eddy periods. So over here, the currents will be northeastward, in that inshore mooring and inshore areas of our upper south coast. And then when it breaks away, it resumes to southwest. Then you can see in between, we've got these Natal pulses. That's the meanders I was speaking about earlier, that basically just swamp everything out. So it's just currents are slack. The Natal pulse is forming in this area, and then it moves down the coast and starts to move further offshore. So basically, you can see quite a bit of variability in the Natal pulse dominating the record when it occurs. Just a couple of statistics. The Durban eddy is present 55% of the time. Number of eddy days per annum, about 200. Number of eddies per annum, 22.5. The average eddy lifespan is about 8.6 days. And the minimum is ranging from 3 to 19 days. An average number of days between eddy events is 4.3 days. If you include the Natal pulse, which kind of swamps everything out, it averages out to 7.7 days. And then the size of the eddy, 40 to 50 k's wide, 60 to 90 k's long. So that's what we call a mesoscale feature. Now, what's happening with the nutrients and biological productivity? Because that's what all the biologists are interested in. We had 2 cruises. Unfortunately, both of the cruises coincided with times when the eddy wasn't dominant in the circulation. The second cruise, which was in the dry season, was a Natal pulse, so we couldn't use that at all. The first cruise, there was still some circulations evident, although the eddy was moving out of the area. So you can see in the temperature over here, this is depth, basically showing the doming of the thermocline. So it's cold water that's pushed up in the center of the eddy. And you've got warmer Gullis Current water offshore in this area. Then the next one down, which I can't see too clearly. Nitrates. The nitrates. So that's part of your nutrients. You can see that's getting pushed up. And we've got silicates also being pushed up. The important thing is the chlorophyll. Just below the surface, you've got a chlorophyll maximum in this area. So it's important for that biological productivity. This was basically on the right is a chlorophyll depiction from the cruise showing the hotspots of productivity. And as I say, the eddy unfortunately wasn't dominant at this time, but you can see that's at 25 meters depth, but you can see a bit of productivity there. Okay, as I mentioned earlier, I deployed some drifters. So this just gives an indication of where the waters are going and then how important it can be for feeding, for those nutrients feeding different areas. So there's 5 drifters that were deployed. You can see one just shot out with a southwesterly, northeastward currents, but together with a coastal low coming through, so strong southwesterly winds was sufficient to just push it straight out. The one in the blue was the first one we deployed. It was in April 2009. That one did a couple of rotations, did one rotation here before going northward, doing another rotation, and eventually ending up at Belito area. So there is some, okay, bearing in mind this is only surface water, it's getting the top 15 meters. That's where the actual drogue is set. So, but that water is capable of moving northward. Then the other thing is you got other rotations over here that then go southward. So it goes southwestward, and on that sort of outer rim of the eddy, there's some leakage through there. Also, winds playing a role in ejecting it. Some are able to do a rotation and then go out, and then others are just getting ejected. This green one getting ejected straight out into the Gullis Current proper. Now, just to look at where these drifters were going and the connectivity, that first one I said that moved north, eventually ended up at Mapelan. So it moved up to Tugela area, drifted up and down here for quite a while, and eventually went on the inshore area to Mapelan. The other one, as I said, ended up at Belito. Then what we're looking at increasingly now is what's happening to the ones that are going south. There's no surprises here. It's got into Natal pulse circulation. So as I said earlier, you've got these Natal pulses, these meanders, which then meander quite a bit offshore here. And then doing what a Gullis current does, some going into retroflexion. One ended up at Cape Columbine, and another one into the South Atlantic, leaking into the South Atlantic Ocean. Okay, what we are looking at more now is the Durban breakaway eddy and the importance of that. Thanks. You can see here an example. This is in September 2009. An eddy over here. There's another one that's breaking away. So this one's already breaking away. This one is still residing here. So it's pulsating. This one then moves down to Cape Morgan and East London. While this one is still stationary. So you can see it actually gathers, once it's starting to move down here, it then gathers speed. So the downstream propagation speeds of the eddy are generally slower in the north, where it's still sort of attached to sort of the area closer to Durban, about 7 kilometers a day. But as it moves south, it then starts to gather momentum, and we had quite a high speed of 28 kilometers a day. So to show you a bit of a complicated slide, it's almost the last one. Basically, this is at Cape Morgan, in East London, and off the Fish River. So you can see in the currents. Now this is showing current direction and current speed. So the current is, and this is depth over here, and time during the time when I showed that previous slide. So you can see here the currents here are southwestward, and the blue denotes a northeastward current reversal. So you can see in this one that as this eddy has then broken away and passed through that mooring, you can see a reversal in the currents. And at the same time, the speed has reduced. So that the blue is a reduction in speed. The greens to reds are higher speeds. So you can see a reduction over here. Is that there was a slight temperature decrease. That's temperature at the same mooring. Whereas further south, as it goes further south, that reversal is only evident at lower depths. But you can see a drop in the velocity. And the same when it gets through almost Port Alfred, it's hardly evident. It's only evident right at the bottom as a slight reversal and a drop in speeds. So those eddies are progressing all the way through. Okay, just some conclusions. That upward doming of the thermal structure in the center of the eddy, it's important for moving nutrients higher in the water column and stimulating primary production. The drifters indicate surface water exchange northward on the inshore part of the Agulhas current and into the northern KZN bight, and southwards into the Agulhas current. Leakage occurs southwards from the outer rim of the eddy into the inshore boundary of the Agulhas current. Satellite imagery shows eddy shedding as the eddy moves south inshore of the Agulhas current, taking biota with it. This is important for nutrient production. Okay, and then the Durban breakaway eddy. I can't read this very well because my eyesight is fading. Okay, so basically it's a transient feature that moves down, and by the time it gets to Port Alfred, it comes through as a lateral wave. Okay, and then the Durban eddy acts as a nutrient pump, so that's basically providing important nutrients and biota downstream of the Durban eddy area. Okay, and I'd just like to thank all the co-authors or contributors and organizations that have helped during this research. Thanks.
Lisa.